My name's Daniel Mitchell, I'm 27 years old, I'm a research associate at the University of Glasgow, and today I'm discussing my research as a visiting student researcher at Caltech. In this research, we utilised a non-invasive brain-computer interface which uses sensors on the outside of your head to monitor the frequencies which your brain emits. The human thinks about different movements, such as grasping your hands, where a deep neural network decodes the brain signals collected and translates this into commands for the robot. In terms of innovative techniques, we utilised two inexpensive 8-channel devices and programmed them to work together to create a 16-channel device, where the sensors sit on the outside of the brain. This can be compared to the neural chip created by Elon Musk's team, which is required to be implanted within the skull. This research is important as the sensors in our work sit on the outside of the brain, which makes it much safer. In terms of real-world applications where this research is highly important, currently quadriplegics have no method of controlling a wheelchair other than eye gazing and blinking, which can be tiring and uncomfortable due to eye strain. Our method simply requires the user to imagine a command which is more comfortable and does not require a screen to look at. Some of the challenges that we encountered in the project included large volumes of datasets that were required to be taken when validating the model across individuals, which results in fatigue and a rapidly degrading model once validated. In addition, brain patterns also differ throughout the day too. We managed to overcome this requirement to take large amounts of data via our deep neural network approach, where we decreased the volume of data required by 70% when compared to the state of the art. We utilised 4 test subjects where our results achieved 78% accuracy using a single-day validation test and also 75% accuracy across 3 different days. For real-world testing, the human's brain was linked directly to the robot via the brain-computer interface, and we achieved an average of 62% accuracy across the 4 different participants. It was really great to be a test subject within this investigation, where I can officially say I controlled a robot using literally my brain. In terms of my experience as a visiting researcher at Caltech, this collaboration has given me a huge amount of exposure to pioneering research and new perspectives to how researchers operate and do their exciting projects at Caltech. In terms of my motivation, I wanted to experience and learn from top engineers in the field of robotics within Professor Chung's lab. How is their approach different to robotics, and hopefully transfer these key learnings into my future research. So in terms of my future impact in my research, I want to continue to work on research which benefits people. Robotics and artificial intelligence has several opportunities to do this within the energy sector and in improving people's lives in the day-to-day also. Following the completion of my PhD, I'm now working on the transit project at the University of Glasgow, which is utilising digital twinning to provide assurances in the strategy and new radical changes required to achieve net zero across the UK. In terms of my advice for aspiring researchers, I was quite nervous when considering my different options abroad, but looking back now, I have absolutely no regrets about going. I gained so much knowledge, as well as learning so much about myself and what I'm able to achieve. In terms of life outside the lab and the culture, I can confirm it's not all about work too in Los Angeles. Whilst I was at Caltech, I took part in High Rocks LA, a Pasadena sprint triathlon, and of course, I wouldn't be Scottish if I didn't manage to fit in some beers and great food with the team. If this research has interested you, you can find out more via my LinkedIn profile, my Smart Systems Group University of Glasgow YouTube page, or even check out my @RobotMyths TikTok page. Thank you very much.